Good morning, grasshoppers. This coming week, we are approaching Chapter 6, Propositional Logic. And I've divided Chapter 6 up into two sections. And I want you to spend this coming week really focused on the first section and your first exercise, 6.1. So I wanted to take an opportunity and just sort of run through this material with you. One of the things that we've been looking at is ordinary language. And as your text points out, unfortunately, however, ordinary language or linguistic usage often obscures the form of an argument. So we have been looking at formal and informal, valid and invalid arguments. And now we're going to get into the approach to what's called the logical calculus. And there are steps that you need to go through. One of them is doing the translations of statements into a form with connectives, which this first section covers. And from there, then it goes on to argument forms and truth function, which we'll be covering next week. But I want you to take this chapter seriously, especially the first part. It's a lot of reading. It's not particularly easy. But if you go slow and you take your time, you will get through it just dandy. So let me look on page 328, and they introduce you to the 5 connectives for language, and I give you a number of examples. So the first one is the tilde, and it is the negation sign. So if you have a statement like Jeannie is a woman, and we can symbolize that as the letter W. The tilde negates that statement. So W is the proposition that Jeannie is a woman. Not W is the negation of that statement, which means that Jeannie is not a woman. So the tilde, it is not the case that. I like that. It's not the case that. The second operator is the dot, or the conjunction. We call it the dot. And it means that Jeannie is a woman and lives in Seattle. So that would be W.S or W.L, however you wanted to translate that for your argument. The wedge, or when I was an undergrad, we called it the vel, but the wedge is a disjunction. Jeannie is a woman, or she lives in Seattle. Now, there are two senses of or. One is the inclusive and one is the exclusive. So as we go through the chapter, your chapter does mention the inclusive sense and the exclusive sense. Of course, you know that inclusive would be that both V or W are included. Exclusion means it's V or W, one or the other, but not both. So we'll just so that you're aware of that little distinction. The horseshoe. Ironically enough, your textbook gives you the horseshoe on page 328. I'm just going through these symbols. I hope you have your textbook open. So the horseshoe they're showing you, it's like this. When I was an undergrad, it was the other way. Very simple. The other notion is that you can do the conditional statement with an arrow. So P arrow Q would be if P then Q. Just so you're aware of that. But we'll be using the horseshoe as, to capture if then. As a side note, try to keep in mind that all arguments are conditional statements. All arguments are if P is a case, then Q is a case. And the antecedent, which they'll go in the chapter, the antecedent are the statements that come before the conditional. So P, if P, then Q. P is the antecedent, Q is the consequent of a conditional statement. The P can be multiple statements. So if P and Q, parentheses, W and S, close parentheses, you see where I'm going? So you can have a number of statements in that antecedent category. The last one is the trip bar, triple bar they call it. We always called it the trip bar. And it is if and only if. So it is what we call a biconditional statement. And it means that P is the case if and only if Q is the case. And it is just a more severe capturing of a linguistic statement than if P then Q. And they give pretty good examples here in your textbook of these connectives. But these are the 5 connectives that you must master. And you really need to focus on those this week. You need to practice with them. I've given you 16 statements in 6.1. I could have given you the whole thing. If you're going to really be on top of this, you're going to want to do as many of those as you can. And that way you get great practice on translating ordinary statements into these symbols, using these connectives. That becomes critical for the remainder of 6.2, and then when we get into the calculus, deductions. Now, why do this? Well, we've been looking at validity and formal and informal. Where we're going with this is that the symbolism that we're going to be looking at is a simplification process. Your text makes it very clear that all you have to do is just look at a form, if P then Q, P therefore Q, and you know the argument's valid because it occupies that form. And so as you translate that, if Jeannie is a woman, then she lives in Seattle. She's a woman, therefore she lives in Seattle. That is a valid argument. Now, it might not be sound, and of course we know that if it's not sound, it's valid, but it's not true. So I just want to sort of prep you that where we're going, excuse me, is a notion that makes it a lot easier to determine the validity or invalidity of an argument. And so the symbolism that we're going to be using is very important that you master this. Take some time, read this over, study it, and you'll be just fine. On 329, they give you examples of each of the connectives, of the tilde, the condition, the and, the vel or the wedge, and the conditional and the biconditional. And I didn't see anything in particular here that was, on page 330, what happened to my thing here? Come on. Okay, there we go. My Mac kind of went dark. I went, arg, we don't like that. So the main operator, and you'll notice that the main operator is what will become very important for you when we're doing truth functions. And what the rest of this section shows you is we're trying to eliminate ambiguity. So A dot B dot C is an ambiguous statement. And we need to know if they're separate or if it's A and parentheses B and C, or we can look at A and B or C as a more ambiguous proposition. So the connectives and the parentheses that are going to come into play, they help really clarify and eliminate the ambiguity in a statement. That's what we're looking for, is non-ambiguous. So we're going to be looking at the main connective, and you'll notice on page 330 they give you several pretty complex statements here, and what they're showing is in the third one that the parentheses separate the two conjuncts, and so that eliminates any ambiguity, but the dot becomes the main connective. Now, I don't want to get too far ahead, but when we look at next week and we look at truth functions, so the truth function, you will be solving for the dot here. Okay? Just if you want to go ahead and look at the rest of chapter 6, you certainly are welcome to do that, but that's going to be for next week. The other notions, on page 332, please make sure that you understand the distinctions between sufficient and necessary causes. So if you're looking at a sufficient condition, then that means that if P, then Q, P is a sufficient condition for Q. If you're looking at a necessary condition, your text gives you a couple of good examples. Hilton's opening a new hotel is sufficient condition for Marriott's doing so, if H then M. That's the way that would be translated. Hilton's opening a new hotel is a necessary condition for Marriott's doing so, if M then H. So you can see how we symbolically manipulate sufficient versus necessary conditions. And these are terms that are going to come up for you later in your life and whatever, so you want to make sure you understand those clearly. Yeah, then they talk about biconditionals, and they give the notion on page 334 of the distinctions of the wedge. So you can make sure you read that over. Eminent logicians, Gottfried Wilhelm Leibniz. You have to, if you're a philosophy major, you become very attuned to Leibniz. He is a very, very important figure in the history of philosophy. The guy was just the other side of brilliant, and developed calculus. He developed all kinds of stuff, and he was a very important logician. So anyway, you can read that over for your entertainment. On page 336, they're looking at well-formed formula. So that's what we're working at, well-formed formula, or what are called WOFs. There's used to be, I'm not sure if they still make Wolf and Proof, but it was a game that you rolled dice, and you would have well-formed statements premised on those die. And that was used in logic courses way back in the olden days. I can remember having, in fact, I may still have a Wolf and Proof game around here somewhere. And it was primarily used for what was called the Polish notation of logic. And we don't normally subscribe to that. It's a different formula, a different formulation of logical statements. But Wolf and Proof was really geared for that. But in any way, we want to just use the notion of well-formed formulas. And that's where we're headed in the next couple of weeks. We're going to be doing that. And again, I want to share with you that as kind of complicated as this stuff seems, it's really not. You just need to go very slow through it. You need to make sure you understand each step and each conditional and each connective in terms of what they do and how we take statements and translate those into symbols, P, Q, R, S, whatever we're using. And then we put those into formula or well-formed statements. And then once we do that, then we can implement what's called truth function. And the truth function is an easier form of determining validity. Everything in logic is about trying to find validity. And that's where we're going. And when we do truth functions next week, then there's a big, long kind of formula that you use, and lots of T's and F's and all that kind of stuff for truth and false. And then at the end, I will show you, bam, what's called the indirect method of truth function. And here you go. Man, this is like so easy. But we have to go through these steps so that we can get to that point. And then after that, in weeks 7 and 8, we'll be doing deduction. And that's where we're looking at these statements, and we're sort of piling them up into argument forms. Modus ponens, modus tollens, hypothetical syllogism, De Morgan's, rules, what are called rules of inference. And there are 19 rules of inference. We're not going to get to them all. But we're going to get a basic framework of the rules of inference. That's where we're going. That's where we're headed. And though it sounds complicated and ethereal and all that, it's really pretty simple. You just have to pay attention. You just have to study it. And you have to really get your head wrapped around that this is important stuff. You're going to be using this way down the road. And, I mean, once you learn it, you'll never not use it. So that's the value of studying logic and getting these notions that we're talking about. So, you're doing a good job. You'll notice that what I have been doing with you is just making sure you're doing the assignments. Excuse me. I apologize. My phone went off. Um, the hang on just a minute here. Okay, I apologize. Sometimes I hate my phone, but in any event, um, let's see, where was I? So we're going there, and and you're gonna be good. Oh, I know what I was gonna say. I apologize. I got mixed up. The phone. I hate you. Um, so up until this point, I've just been trying to make sure you're doing the assignments. You get some of them wrong. I understand, but that's part of the ambiguity of language when we're looking at formal and informal. Sometimes it's easy to get that mixed up a little bit, or you pick the wrong informal fallacy. Where we're going now corrects all that. It corrects that ambiguity in terms of validity. The informal fallacies I will share with you, you want to review those. You want to keep those in mind. There are probably 7 or 8 of them that you'll use all the time. Ad hominem, straw man, non sequitur, things of that nature that you'll use a lot. Actually, I have several books here that have literally hundreds of informal fallacies. You're never gonna master all of that, and they really all boil down to about 20 or 25 informal fallacies, but they're just different variations. A very well-known Jessica Goldman is a female philosopher, a novelist, and has written some very cool books. She wrote a good anthology of informal fallacies, and so there are those books out there. You might want to just humor yourself and get one. Okay, you have any questions, drop me an email. I think you've been doing very good about that, and I'm trying to get back with you as quickly as I can. Normally the same day. I come in every morning and I look at your email, I look at your scores, I grade papers, which is what I was doing this morning already. So I think you're doing a good job. And once again, as I shared with you last week, the fastest way to get in the heater in my class is don't do the assignments. Now, for exercise 6-1, I want you to know that I'm going to be looking at those pretty carefully. So please take your time with those. Don't rush. I want you to take your time. You start rushing through this stuff, and I guarantee you're going to regret that. So take your time, study it, go over it several times if you want, piece by piece by piece, and that's the way you'll integrate that and master this material. Okay, sports fans, you have a good week, and I will be in touch.